Hi, good afternoon. Okay, so today I'm going to present by using the slides. Okay, and then if you would like to get the slides, you can join my WhatsApp group. Okay, so this is a discussion group. So in the group, you can send me a direct message. Then, so if I think the questions worth discussions, then I will post a response to your questions. Okay, and also the notes and the practices related to this class will also be uploaded to the WhatsApp group. So if you would like to access to the notes, slides, and practices, then you can join the WhatsApp group. Okay. So the topics of discussions of today is ionic bond. Yep, ionic bond. Okay, I believe that most of you have learned chemical bondings in your school. Okay, and then you should learn that for elements, they most of them are not stable, and if they would like to become stable, they need to achieve a special arrangements of electrons called the duplets or octet. Yep, that is what you should have learned. And today we are going to learn how these atoms they become ions, okay, to achieve octets and duplets, and after that they form the chemical bonds. Okay, so let's start with formations of ions. Okay, ions is an atoms or group of atoms carrying positive or negative charge. Any particles that carry charge is called ions. For example, calcium, the charge is 2 positive, oxide, sulfate. So these are ions. If a particle has equal numbers of protons and electrons, proton carry positive charge, electron carry negative charge. If the number of protons and electrons are equal, then the charge is 0 because they neutralize each other. And we say the particle is neutral. Yeah, the particle is neutral. Okay, so that is what you need to know about ion. During the chemical equations, during the chemical reactions, what happened is that these electrons in the atoms, they may be transferred. Yeah, it may be transferred from one atom to another atom, or they will be shared between atoms in the chemical reaction. Okay, sharing electrons will be discussed in another lessons called the covalent bonding. And for today's lessons, we are discussing ionic bonding. So we are talking about transference of electron from one atom to another. So in the chemical reactions, electrons can be transferred from one atom to another atom. In the case where electron is removed, it means we take out the electron from an atom. Yep. Okay. The number of proton will be more than number of electrons. So just if you still remember, just now we say that the number of protons and number of electrons in an atom is the same. Numbers should be the same. But if we take out electrons, leaving the proton inside, then the proton will be more than electrons. Then in this case, the atom will has excess positive charge. The positive charge is more than the negative charge, and then the ions form is a positive ions. Okay, so a positive ion is also called a cation. Yeah, there's another name for positive ion. It's called a cation. And if an atom gains electrons, then the excess negative charge in the atom, and there is an excess negative charge in the atom. Okay, because electron is more than proton, so then the ion will be negative. Yep. So release electrons or give away electrons, then it will become positive. If we receive electrons, that will become negative. Yeah, that's how the positive negative ions form. Okay, the negative ion is called anion. It's not written here. Okay, so let me write down. The negative ion is called anion. A-N-I-O-N. Anion. Okay. Okay, so in other words, the atom losing electrons from a positive ion and is usually a metal, and the atom gaining electrons from a negative ion called anion and is usually a non-metallic element. Yeah? Usually for metal, it tends to give away the electron and form positive ion, and for non-metal, they will tend to receive electrons and become a negative ions. Yeah. So let's see a few examples. This formations of positive, negative ions. Okay, formations of positive ions. Okay. So let's see this case. We have a sodium atoms here, and the electrons arrangements. What's the electrons arrangement for this sodium? Any idea? You can type your answer in the chat room if you. What's the electrons arrangements for this sodium? Okay, so if we want to know the electrons arrangement, first, of course, we can see from the diagram. Okay, second, we can predict from the number of electrons. So this is an atom. It has 11 proton, and it is the number of electron must also be 11 because in atom is neutral. Atom is neutral, so the number of protons must be equal to the number of electron. So therefore, the electron arrangement is 281. 281. The first shell has 2 electrons, the second shell 8 electrons, and then the third shell has 1 electron. Okay, so what's the charge? The charge is 0. The charge is 0. Okay, because the number of proton equal to number of electrons. Okay, this is in the notes. This is given in the notes. So if you want to get the notes, then you can you can access it from my WhatsApp group. Okay, I'm going to upload it to the WhatsApp group one more time. Okay, after the class, so that's if you join the WhatsApp group now, then you can download it from the WhatsApp group. Okay. If you don't want to join the WhatsApp group, actually, after you join and then after you download the notes, then you can you can leave the group. It's also okay. I have no problem with that. Okay. Okay. So now we have a question. Okay, is this arrangement an octet? The answer is no. Why? Because for octet, it must have 8 electrons in the outermost shell. Yeah, this one only have 1 electron, so therefore it's not octet. Okay, it's not octet because it doesn't have 8 electrons in the outermost shell. Okay, so no, it's not octet. Okay, it's not octet. So if it's not octet, then it's not stable. So it's not stable. Okay, so these atoms, the electrons arrangement is 281 and it's not stable. Okay, and you should have learned that if it's not stable, it tends to become stable, and the way that it becomes stable is to release its valence electron. So it releases 1 electron. After releasing 1 electron, then the electrons arrangement become this 281. So now the number of electrons is 10. Okay, after releasing 1 electron, 10, and the electrons arrangements become 2, 8. 2, 8. Okay, so now what's the charge now? 11 proton means the charge is positive electron, and 10 electron means the charge is negative 10. Okay, and this one for positive 11 and negative 10, the net charge will be positive 1. Okay, so the charge is positive 1. Okay, so now is this octet? Yes. Why? Because we can see that it has 8 electrons in the outermost shell, or we see here. Okay, the outermost shell has 8 electrons, and is it stable? Yes. Okay, octet means stable. Okay, so that is the ideas of formations of positive ions. Okay, initially not stable, so it releases electron, then it achieves octet, and then it becomes stable. Okay, so this is an example of formations of positive ions. Okay, so far, any questions? Okay, no questions, then let's continue. Let's continue. Okay, so next examples. Magnesium. Magnesium is a metal, and it has 12 proton. 12 proton, and the number of electron is also 12 because number of proton must be equal to the number of electron, and the electron arrangement is 282. 282. Okay, so what's the charge? 0, because number of proton equal to number of electrons. Is it octet? No, because the number of electron in the outermost shell is 2 and not 8. So not stable. Not stable. So, and then it's not stable. It tends to release 2 electrons. Release 2 electrons. After it releases 2 electrons, the number of electrons will be 10. 10 electron. The arrangement will be 2, 8. Okay, so the charge will be positive 2 because we have 2 proton more than the electron. Okay, yeah. So after it form it release electron, it form ion. So okay, so we write magnesium. Okay, you don't need to, when you draw this dot and cross diagram, you don't need to draw this circle inside. Okay, this one actually shows nucleus, but actually you don't need to draw that. Okay, you just label magnesium and then draw the first shell. Draw the first shell. The first shell has 2 electrons. Okay, and then the second shell has 8 electrons. Okay, now to label this 8 electron, we have a few ways. Okay, sometimes we will draw like this. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, there are reasons that we draw these electrons in pair. Okay, or we do not draw them in pair, but we draw them far away. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Okay, the reason that we draw it like this is because electrons carry same charge, then they will repel each other, so they will be as far as possible from each other. So therefore, we draw them all distributed far from each other. Okay, so if it's an ion, then we will put a square bracket and then put the charge at the upper right corner, 2 positive. That is how we draw the dot and cross diagram for an ion. Okay, so that is how the formations of magnesium occurs. It releases 2 valence electron and then form ions. Okay. Okay, we have another case, aluminium. Aluminium has 3 valence electron. It's not stable. Yeah. So for atoms, it has 13 electrons. The electrons arrangement is 283, and therefore it's not stable. Charge is 0. Not octet, not stable. Yep. So then it will release the 3 electron. After releasing 3 electrons, then the number of electrons will be 10 electrons arrangement, 2, 8. Then this become stable. Okay, its octet is stable, and the charge is positive 3 because we have 3 protons more than electrons, and the dot and cross diagram, we draw 2 electrons in the first shell, and then 8 electrons in the outermost shell. Okay, and the charge is 3 positive. 3 positive. Okay. Okay, so that is the formations of positive ion. Okay. Now let's continue with formations of negative ions. Negative ion. Let's see how negative ions form. Okay, in this case, we have a fluorine atom. It has 9 protons and 9 electrons, and the electrons arrangement will be 2, 7. And the charge is 0. Okay, now 2, 7 is very hard for it to throw away all its electrons. Okay, so then it will be easier for this fluorine to receive an electron. Okay, 2, 7 is not octet and is not stable. So to become a stable, it will release it will receive an electron. Okay, you have the electron, and then the electron will go into the outermost shell. Okay, so after it receives 1 electron, then the number of electrons will become 10. Yep. Initially it's 9. Initially is 9. Now it becomes 10. Yep. Then the electrons arrangement will be 2, 8. Yep. 2, 8. Okay. So what's the charge? Okay. Now we have electrons more than proton. 1 electron more than proton. So the charge will be -1. Okay. Because the charge of electron is negative. We have 10 electron, -10. This one +9. So the net charge is -1. Okay, this is the net charge. Okay, is it octet? Yes, because it has 8 valence electrons. It is octet and it's stable. Okay, and then for the electrons arrangements, the first shell 2 electrons, and then the outermost shell. Okay, usually we use the cross, another symbol to represent the electron it received from the others. Okay, so therefore the last electron I draw a cross instead of the dot. Okay, this is called a dot and cross diagram. We use dot and cross to represent the electrons. Okay, then we put the brackets, and then the charge is 1 negative. Okay, yeah. So that is the formations of the negative ions. Okay, another case, oxygens, 8 protons, 8 electrons, electrons arrangement 2, 6. So not octet, the charge is 0. So for oxygens to achieve octet, it will receive 2 electrons. So oxygens, then you receive 2 electrons, then it will become something like this. 1, 2, 3, 4, 5, 6, 7, 8. Okay, it received 2 electrons. Receive 2 electrons, and then so after receiving 2 electrons, the charge become 2 negative. So number of electrons 10. After initially is 8. After receiving 2 electrons, become 10. Okay, electrons arrangement 2, 8. Yes, is octet and is stable. And the charge is negative 2 because we have 2 electrons more than proton. Okay, yeah. So that is the how the positive ions and the negative ions form. Okay, the reason that they form positive negative ion is because they want to achieve octet, which is stable arrangements of electrons. Yeah. Okay, so now fluoride ions versus neon atom. Okay. If you refer to the periodic table, yeah, you will find that fluorine is next to neon in the periodic table. Okay, and if you check the number of electrons and also the arrangements of electrons, then you will find that the fluoride ion and the neon ions are the same. Yep. Okay, the electrons arrangement is 2, 8. 2, 8. This is also 2, 8. Okay, yeah. So after forming an ion, the electron arrangements of the ion is similar to the noble gases. Okay, and that's the reason they want to form ion, because they want to form ion is because they want to achieve the octet arrangements of electrons. And all the group 18 has the octet arrangements of electrons. So it means they want to become like the noble gases, because noble gases are very stable. So if they want to be stable, then they will imitate. Okay, well, okay, let's say it's imitate. Okay, this is a group 18. Okay, yeah. Mm-hmm. Okay, the electron arrangement is the same, but chemically they are totally different. Chemically they are totally different. Okay, the reason is because this by nature is already in octet. Okay, it doesn't receive electron, it doesn't donate electron. By nature, initially is already in octet. They are very stable. This one, they achieve octet by receiving electron, and this make it carry charges. When you carry charges, then you become chemically active. Okay, yeah. Mm-hmm. So the fluoride ion and the neon ion have similar electron arrangement, but the fluoride ion carry charge, whereas neon atom is neutral. Okay, in terms of electron arrangement, they are the same, but neon has no charge, but fluoride has charge, and this make them chemically very different. Okay, yeah? Okay, so that is the formations of ion. Okay, now let's see ionic bonding. Okay, what happened after they form positive negative ions? Okay, they will form a chemical bond, and the bond is called ionic bonding. Ionic bonds are formed by one atom transfer electrons to another atoms to form ions. Okay, I'll show you an example later. So ions are atoms or group of atoms which have lost or gained electron. Yep. So ions, they form because they lose electron or gain electron. So if they lose electron, it will form positive ion, and if it's gain electron, it will form negative ion. Okay, so the ions of opposite charge will attract one another. You see, one donate electron, one receive electrons. Okay, so one will become positive, one will become negative. And if we have positive negative charge, the charge is opposite, then they will form a strong attractive force, a strong electrostatic force. This is an attraction force. So this attraction force will create the ionic bond. So ionic bonds form when there is a positive ion and negative ion, and then they have electrostatic force that hold them strongly together, then that is ionic bond. Yeah, I'll show you an example later. Ionic bond is also known as electrovalence bond. Yeah, electrovalence bond. There's another name for ionic bond. Okay, so let's see this example. We have sodium atom, we have chloride atoms. The electrons arrangement for sodium is 281, not octet, not stable. For chlorine is 287, so it's also not stable. Yeah, these two are not stable. When they meet each other, then they will see, hey, you are lack of one electron. I have one electrons extra. I don't like these electrons. So how about I give these electrons to you? Yep, that's sodium. Okay, and chloride say, yes, of course, because I'm short of one electron to become stable. Yep. So of course, okay, I will be happy to accept your electrons. So then the sodium will give its electrons to the chlorine. Yep. Okay, after giving the electron to the chlorine, then the sodium will form sodium ions, Na, and then 2, 8. 2, 8, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So then the charge is 1 positive because it released 1 electrons. So it will be 1 proton more than electron. Okay. So the chlorine received the electron. So then this one, the arrangement is 2, 8. Okay. Chlorine received the electron, the arrangement will be 2, 8, 8. 2, 8, 8. Okay. So we have chlorine. Okay. 1, 2 electron in the first shell. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so 8 electron in the second shell, and then we have third shell. Third shell also 8 electron. Initially it's 7. Now after receiving 1 electron, it becomes 8. Okay, so we put a dot here to indicate that this electron has come from sodium. Okay, then it will form a negative charge ion. Okay, so when we have a positive and negative charge ions, then they will create, or they will produce a strong attraction force between them. Okay, so they will create, let's say, a strong attraction force. Okay, this is an electrostatic force. Electrostatic force. Electrostatic force is a force between charges. Okay, so this electrostatic force is the ionic bond. Okay, this force that hold the positive negative ions together is called the ionic bond. Okay, and these things, okay, they're formed by positive negative ion is called the ionic compound. Okay, so the compounds, okay, which they form because of this ionic bond is called the ionic compound. Okay. Okay, so far, any question? Okay, if no questions, then we continue. Let's continue. Okay, if you want to get the slides or the notes, okay, you can join the WhatsApp group. The link to the WhatsApp group is given in the description also. Okay, if you want to join through the QR code, so this is the QR code. Okay, or else you click on the link in the description, so you can join through the descriptions. Okay. Okay, so we have 5 minutes left. Let's see this the last 2 examples. Okay, so this is between magnesium and fluorine. Okay, the electrons arrangement for magnesium is 282. 282. 282. Fluorine is 27. 27. So magnesium has 2 extra electrons, so it will give its extra electron to the fluorine. So that it will form magnesium ion, Mg. The first circle is the first shell. First shell, and then the second circle is the second shell. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then the charge will be 2 positive. Okay, so fluorine, after receiving electrons, then it will become 2, 8 also. one, this two, okay, 1, 2, 3, 4, 5, 6, 7, 8, and the charge is 1 negative. And then we have another fluorine. 1, 2. Yep. Okay. That is the ionic bond. Yeah. And this is ionic compound. This is magnesium fluoride. Magnesium fluoride. This the formula is MgF2, magnesium fluoride. This is an ionic compound. Okay. Yeah. Okay, this one is more or less the same. Okay, calcium. Okay, I think we skip this one now. Okay, more or less the same. And then let's see. Okay, so this is questions that may be asked in your test or exam. They say, oh, by using sodium and chlorine atom example, explain how ionic bond is formed. Okay, so when in exam, this usually come out in the essay questions. Essay questions, they will give you, this question is, I think it's 4 marks. 4 marks questions. So they will ask you to explain the formations of the ionic bond in between sodium and chlorine. Okay, so the very first thing is you must tell that the electrons arrangements of sodium and chlorines are not stable. So electron arrangements of sodium atom is 281. So in the chemical reaction, it will releases 1 electron to achieve a stable octet electrons to form sodium ions. So this 281 not stable. So to become stable, they will release 1 electron. After it release 1 electron, then it will become sodium ions. So it will form sodium ion Na positive with electrons arrangement 2,8. Okay. So first you tell that, okay, the electron arrangement is not stable. Then after that, you tell that, okay, to achieve stable electrons arrangement, so it will release its electron and form the positive ion. 2 marks. Okay, electrons arrangements of chlorine atom is 287. In a chemical reaction, it will receive 1 electron to achieve stable octet electrons arrangements, and the electrons arrangement will become 288. Okay. So after they form positive negative ion, then the positive and negative ions, or the sodium and chloride ions, are attracted with strong electrostatic force. Because opposite charge, then they will have a strong force, make them attract to each other. Okay, and this is called the ionic bond. Okay, ionic bond. Okay, yeah. So this is a sample questions, okay, that may come out in your test and exam. This actually is quite frequently asked questions. Okay. Okay, so then you need to know the points that you need to give when you see these questions. Okay. By using the dot and cross diagram, show the formations of each ionic compound. Okay, this one actually is they want you to draw the diagram like this. Okay, yeah. So we don't have time now, so I will skip these two. Okay, similar to this, very similar to this. Okay, so this is this diagram actually it shows the formations of the this ionic compound. Okay, so I want, and what I want to cover is this one, predicting the formula of ionic compound. Okay, you should have learned this in periodic table. Okay, if the atoms of metal from group 1, then the charge will be positive 1. Okay, so to predict the formula, we need to know the charge. Okay, so for ions from group 1, the charge will be positive 1 because they will tend to release 1 electron. So group 1, the charge will be positive 1, positive 1. Group 2, they will release 2 electrons, then the charge will be positive 2. Positive 2, positive 2. Okay, group 3, then you will release 3 electrons, then the charge will be positive 3. Okay. Now for non-metals, they will receive electron. For group 15, if you want to become stable, then it will receive 3 electrons. Okay, receive 3 electrons, the charge will be negative 3. Group 16 receive 2 electrons, -2, and group 17 receive 1 electron. Okay, so how many electrons receive or how many electrons release depends on how many the electrons transfer to make them become octet. Like 15, the electrons arrangement is 285. 285. 285 means is a lack of 3 electrons to become stable, so it will receive 3 electrons. Receiving 3 electrons make the charge -3. Okay, so group 15 charge -3, -2, -1, and this one -3, -2, and -1. This is the charge. Okay, so after we know the charge, okay, then we can write the formula. Okay, so the formula will be the charge of the negative and positive ion must be balanced. Okay, for example, group 1 +1, group 15 -3 means that we need to have 3 metal M. Yeah, 3 metal M to balance the negative charge, the -3 charge of -3. Yeah? Okay, so so then M we have 3. Yeah? Okay, so 3 ions of M, so we write M subscript 3. Okay, and 1 ions of N, so we write N. This is the formula. Okay, this is the formula. Okay, examples: aluminum chloride, AlCl3. Okay, aluminum chloride. Okay, for this one, okay, the formula to balance the charge, we need to have 2M. Now the charge is +1. Okay, so we need to have 2 metal M to balance the charge, so it becomes M2. Okay, M2N. Examples, let's say magnesium chloride or magnesium bromide, Br2. Okay, then the last one. Okay, now this one, the charge is already balanced. The positive and negative one is already balanced. It means we just need 1 N and 1 M. Okay, then this is the formula. Okay, for the fourth case, group 2, we have 2 positive, 3 negative. So to balance the charge, we need to have 3 ion M and 2 ion N. Then the charge will be +6 and -6. Okay, then balance. Okay, so this one, the charge is already balanced, so just Mn. This one, Mn2. Mn2. Okay. This one Mn. Okay, this one M2 and 3, and this is Mn3. Okay, I just realized that the formula, the example I give here is not correct. Okay, yep, so not correct. So we ignore this, huh? Okay, so this is formula. Okay, so in exam, okay, another question that may be asked is predicting the formula. Okay, for ionic compound and also for covalent compound. Covalent compound we will discuss in next lessons, most probably next Monday, same time. Okay, covalent compound. Okay, so yeah, I think that's all. That's all for our class. Yep. So if you want, again, okay, if you want to get, you want to access to the notes, slides, or practices, okay, join the WhatsApp group. Here we have 4 WhatsApp group. Okay, so if you want to get the notes for chemistry, then join the first one. Okay, Form 4 chemistry, or you can click on the link in the descriptions. Yeah, the link in the descriptions. Then you can also join from there. Okay, so I will upload the notes and also the slides. Okay, and also there's one practice I would like you to do. There's online practices I would like you to do from the group. Okay, yeah. Okay, so that's all. Yeah, that's all for today. Thank you very much. So I hope that I can see you next week. Okay. Yep. Bye.